Let's look at E. Well, on E, we've got the 1/3 exponent, which means this is going to turn into a cube root of, well, what's inside the parentheses here on E is a -64. So the -64 will be on the inside of the cube root. So this problem is asking, what number multiplied by itself 3 times is a -64? Well, luckily when we have odd roots, if you multiply a negative number by itself an odd number of times, it will stay negative. So on this one, what negative number multiplied by itself 3 times gives us a -64? Well, that's just the number -4. So that's our solution. On F, what do we have here? We have a 1/4 exponent, which means we have a 4th root of what's inside of our parentheses. Well, what's inside of our parentheses is a 1/16th fraction. So you're asking, what multiplied by itself 4 times is going to be 1/16? Or what you can also do with fractions is break this up by taking the 4th root of the top and the 4th root of the bottom separately, which this now would translate into, what number multiplied by itself 4 times gives you 1? Well, there's only one number that does that, and that is the number 1, divided by, let's see, what number multiplied by itself 4 times gives us 16? Again, there's only one number that does that, and that's the number 2. What this also means is what number multiplied by itself 4 times gives us 1/16? Well, that was 1/2. So just to review, whenever we have a fractional exponent, whatever number is on the bottom of the fraction will be whatever type of root it is, and whatever number is on the top of the fraction will be your ordinary exponent. The ordinary exponent can go on the inside of the root or on the outside of the root. It does not matter. Now, even though it technically doesn't matter which one we do first, the exponent or the root, it's often easier for us to take care of the root first because this will give us smaller values that are much more manageable than if we take care of the exponent first. An exponent would make our numbers bigger first. We would rather make our numbers smaller first by taking care of the root. Even though, like I said, it technically doesn't matter which one you do first and which one you do second. Let's look at this next example, 25 to the 3/2. So technically it doesn't matter if we deal with the 3 or the 2 first, but let's make our lives easier and deal with the bottom first, which means let's turn it into whatever kind of root the 2 will turn it into. Well, the 2 will turn this into a square root of 25, which is 5. Then we'll deal with the exponent of 3 at the end. So now this means we'll take what we just got and we'll make sure we raise it to the 3rd power. We cube it at the end. Well, 5 cubed is just going to be the number 125. And that's our final answer. Now let's look at the next problem. On the next problem, we have a 27 to the 2/3. Again, it doesn't matter where I start on this one, but let's kind of start with the easiest first, which is the 3 on the denominator, which tells us to take a cube root of 27 first. So that means what number multiplied by itself 3 times will give us 27, and that's the number 3. But we can't forget about the 2 that was on top of our fraction. That means that we have to square whatever it is that we're getting out. So at the end here, we have to square that 3 we got out, which is going to give us a 9. Notice, again, we were able to do 2 different problems without the aid of a calculator because we took care of the roots first, because they made our answers more manageable, because we made our numbers smaller first.